Hi, I'm Jasper Laster. I'm a Sports Med 3 student, and my project is on improving the brain. So, the human brain itself is composed of lots of neurons, and neurons are easily the most complex cell in the human body. A neuron is very delicate, and in which once it's damaged, the damage is permanent, and they don't multiply like other cells in your body do. When it dies, it's gone forever, unless it's replaced, of course, through like stem cells. It also runs and works through electrical charges, which is how it forms and strengthens connections with other neurons. They connect through electricity. They're able to connect, and that's how basically you form a new ability to think about something, or that's how you're able to problem solve in different ways. You're able to make new connections. Obviously, it affects things like memory and pretty much all neural processes, considering that your neurons make up your nervous system. Not just the cognitive ones like memory, but also like vision. Although, of course, vision has more stuff going into it than that, but like language, for example. The brain also has a limited number of neural stem cells, which it keeps in reserve for in case you do get damaged, but it really can't repair it. It can only replace, and it has a limited number of that. And it's one of the least understood organs in the human body, and it's due to just how complex it is. But as we try and solve the neurological problems like Alzheimer's or epilepsy, or even try to improve the brain like this project's about, we learn more and more about it. So the ways we can improve the brain, there are drugs like psilocybin and modafinil, which all help to increase memory, and both have just been recently approved for further research by U.S. medical researchers before the drugs were pushed off to the side and weren't even allowed to be studied. The effects of these are more out-of-the-box thinking, improved memory, and heightened alertness. Side note is that both of the drugs have potential for side effects and overuse, and they found that the most effects these drugs had in terms of the positive ones were with people that already had low IQs. We can also use just everyday things that you can incorporate into just your schedule, like, for example, that just practices memory and like analysis and stuff like that, like apps like Luminosity, Cogni Brain Fitness, which is made by neuroscientists, or Portrait Brain Health Teasers. Other ways we're improving the brain is that we use stem cells, which we can actually use to pretty much rewire an entire part of the brain or repair it. We basically remove the dead neuron cell, which we only do this if it's dead. And then we basically replace and repair it. But we can repair an entire subsystem of your central nervous system with this, which is incredibly impressive because doing a whole subsystem at a time is honestly just completely unheard of until like cutting edge research just now. We also have cybernetic options for brain improvement, like neurogenesis, which is where you can use cybernetics, or neurogenesis is basically the process in which the brain's own natural ability to like improve and make new connections and stuff like that, it's basically induced so it's able to go faster. So they use neurogenesis to activate the brain's like reserve of neurons, or are able to use the brain to like make the neurons basically evolve quicker and form connections faster to increase your like cognitive functions and memory and stuff like that. Of course, we can use stem cells to pretty much add the number of neurons in a person's brain. And then with neurogenesis, we can make them become a fully fledged like adult neuron very quickly. So we can actually like add neurons to people. Here are some images of like the neurostem cells and neurogenesis in action. As you can see, this is the neurogenesis of a stem cell normally, and this is it with the increased additive to it. It goes much faster, and it was this effect on mice, as shown. The stem cells were actually able to increase in mass and volume and form more connections through purely natural means. And these are the type of stuff that you have, like implants that they use, like synaptic plasticity, which allows your brain to basically modulate its functions faster, so it's able to make connections, like send it throughout your body quicker. Cortical neuroprosthesis for restoring and improving memory. This is what the main part of the project is going to be about, and that what I'll be discussing. While we already have like neural cybernetics, like as I just mentioned, but most of those cybernetics make use of the PNS, or peripheral nervous system. Like, for example, cybernetic limbs, in which we have them connected to the peripheral nervous system so they can move just like a normal limb by just command through your brain. And when, of course, we use the electrical connections, but basically they're trying to have the connections. Your nervous system is basically supplying the electrical connections. But in the one they're trying to do, they're trying to tap into the central nervous system directly and try and mimic the electrical output that it's doing. And of course, the CNS has a far more complex and intense electrical impulse system than the peripheral nervous system, because that's where all your thinking and higher functions come from. So it was much more difficult to try and match up with the central nervous system as opposed to just the peripheral, considering they were not only having to work with more, but more difficult things. This is an example of like the robotic arm and the electrical sensors. This is the type of like things you do. This is actually a cochlear implant, which they put in, and that can actually help send signals through their electrical ones. Of course, the one I'm discussing, they put in the brain directly, but this is another type of one that they're working on. This is the basic system for a robotic arm, and it works kind of similar to this. Although, of course, I'll show you a graph of all this stuff later. So how the cortical prosthesis works is that it mimics the actual electrical signals that your brain forms and puts it into your neurons. So they start transmitting more information and start doing more functions at like more peak capacity. Like obviously you reach a point where everyone has like a limit to basically where their brain is only firing so many electrical signals at once. But this can basically push you to like overload it and let your brain do even more electrical signals than even you thought you could. It lets you learn new things faster because your brain's forming connections better thanks to the electrical signals that are being sent. It also helps you remember more things because it improves your memory because you're forming the connections, and those connections are permanent, so you'll remember that. It also can help you come up with more out-of-the-box solutions because, as I mentioned, the new connections is you forming something new in your head. So that's a way to, if you're forming more connections quickly, you're thinking of new ways that you weren't even able to think of before because you're just thinking of new ways. It can also help you learn faster because of this same reason. Of course, making new adaptive ways, it just makes them much more adaptive, which, of course, then they would be naturally. Already they're a fairly naturally adaptive thing, but this is only improving on it. So just incredible improvements. How it works is that what they actually did is they had a custom-built 16-channel simulator, which was used to test it and figure out that that's basically what they used to do it. How the prosthesis would function is that it basically, once again, it sends the electrical currents into the brain, right into the central nervous system. But what they found was even more impressive than what the projections were, because it had been a lot more neural potential than what they had expected to get out of it. Like, they were shocked by how much potential the neurons even had and what we're able to handle. So we're learning more and more that the brain has more potential than we even thought they did. And originally they thought they were only able to use like a few select neurons as potential. But instead, with this thing, they were able to get multiple clusters, which showed them that multiple clusters of neurons think together at the same time. And they thought it would be more individual things. So the mice were able to think much faster than the projections were able to like even had them. So thankfully, they had a lot of research materials that were able to thing it, but they were able to get it and understand it. And of course, if they actually improve the design of the 16-channel simulator, they hypothesized that it would have even more beneficial improvements, and that they could think even faster and could get even more out of your neurons. Considering they felt like they didn't hit a ceiling. They felt considering it just kept improving, they didn't hit like the neuron potential ceiling. So it could potentially be even more. Now, the research was shown through the use of an MIMO equation, or multi-input, multi-output, which is basically, and I learned a lot about this, is a mathematical model that deals with several complex structures at once. It's able to measure multiple things going on with the mice at the same time, what's going on with them, and what they're doing as they're going on at the same time. So they're able to not just measure how much they're improving, but how much each cognitive process that they did is improving individually at the same time. Of course, the model's insanely complex, and if I had to put it all here, it would just be a bunch of gobbledygook. But just imagine just the most complex math equation you ever saw in your entire life. It is able to measure feedback of what the processes are doing in the brain. Overall, the model itself is insane. It actually helps measure the potential of the neuron output, like how much potential they thought it had, and then it was able to even measure beyond that. That's how complex it was. It was able to measure for what they didn't account for. And figure out just how optimized they were able to make it. The experiment itself, of course, was run multiple times with a variety of different mice just to get a strong base of research. Optimizing neurons, and right here is an example of an IMMO model, just a very basic one, obviously not nearly as complex, but show they set it in different boxes. But in each one of these is an IMSO, which is this whole equation. So this whole IMMO model is made up of multiple IMSO, which is multi-input singular output model. So that's what that is. The prosthesis optimizes the neuron, and that means that the neurons themselves are able to work at a higher capacity, obviously. This is not only very important for just the future of the world, and it's achieved through an even more complex and delicate process because the neurons are so complex and delicate that they can't just go in there And of course, instead of using the peripheral nervous system, like a lot of other biotech is trying to do, like the arm, they go straight to the CNS. So they have to be even more careful when they're in there as to not screw things up. It's very similar to like deep brain stimulation, which is what they're debating, which is when they send shocks through your body that can even help you maybe get rid of addiction. The revolutionary and important part of the Vultra kernel-based strategy is basically which is what they tried to do to come up with this whole thing, was basically the nonlinear biomedical system, or basically them trying to think outside of the box in terms of medical solutions. Like a whole strategy basically made up of multiple sections of them trying to think outside of the box and not think of what people had already done before. This is obviously what medicine itself is going to need to strive further, because if you keep sticking to what works or what you know to be true, then we'll never improve. And to improve on what we're doing is pretty much the name of the game in medicine, or at least medical research. And it matters it matters a lot, because you can like almost come out of a disease. Like anyone can get a disease like Alzheimer's, but we can now like maybe cure it, or maybe even make you better. Like as they said, basically imagine rewinding the clock. A brain of a 45-year-old turned into the brain of a 25-year-old. And it's important because as we're doing this, we're learning how each neuron functions differently, and we're understanding more about how the brain works itself. And the more and more our technology advances, we could just do this more and more and better. And we could even solve a variety of neurological disorders. And once again, we could even do addiction. And rewriting is, of course, how they figure it'll probably get done. We can just rewrite an entire subsection. And this is what I'm talking about when I say the models of the experiment itself. Shown right here, you have the predicted ones, which is the non-mass decision. And as shown, this is what they're predicted, and this is what they got. Much more intense and much more all around. Intensive firing. This is just a very basic one. And then, of course, the predicted one and what they actually got was crazy. And as shown, they were able to figure it out much faster with what they were able to with the enhancement. It was hardly even a challenge for them, whereas beforehand they kept failing over and over. But this one, they just get the right one almost every time. And here it shows that the stronger codes or stronger data input, the better they did. And when they kept leveling it off, it got lower and lower. So as shown, like the normal one, even when they submitted strong codes with the pretty much unedited mice, it was just still not enough. And here's another visual example of just how the more energy that they did, the better it was. And of course, more nonlinear module. So for the conclusion, not only was the research unusually successful, more so than they had ever thought, more so than they ever thought it could be. I think this is like the mark of a new era in medical technology and advancement. Whereas before we're focusing on fixing issues in the human body and the brain, but now we can make the human body and brain perform better. Of course, this involves a whole moral discussion, but on a purely scientific basis, it's a great thing that reached the point where we can now understand the human body well enough to not only see the flaws and try and help prevent them, but actually improve upon them and make people's lives better overall. Because if we can improve upon the weaknesses of the human body, people's lives would be massively improved. It's also fascinating that this could be a cure for Alzheimer's, Parkinson's, obsessive compulsive disorder, depression, and epilepsy. It's amazing that the cutting-edge medical research, what it's able to do for the human body and its many complex functions, the brain just being one example. And of course, one can only hope. I hope in the future that I can be part of this field of science when I go to college, and that I can really help be on the cutting edge of this. Because what are we as a species if we're not constantly striving to improve? All right, and that's it.